All right, let's talk about something that's becoming a huge deal in AI, accountability. I mean, we're seeing these systems make some really critical decisions, right? In finance, in law, even in medicine. And that brings up a massive challenge. How can we actually trust their answers? The solution, in what we're diving into today, is about building AI that can basically be put on the stand, truly cross-examined.
And this quote, wow, it just cuts right to the heart of it all. It's for anyone who's on the hook for an AI's answers, especially when, because the model said so, is just, well, completely unacceptable. Seriously, put yourself in the shoes of a chief risk officer or a lawyer or even the engineer who just deployed a new system. When a regulator comes knocking or a client is demanding to know how a decision was made because the model said so, that's not just a flimsy excuse. That's a massive, massive liability.
So yeah, this leads us right into what we're calling the AI accountability problem. And the key idea here is moving beyond just model accuracy and into something called epistemic responsibility. That might sound a little academic, but what it really means is that it's just not good enough for an AI to be correct anymore. It has to be provably correct. There has to be a clear chain of reasoning that you, me, anyone can actually follow.
Yeah, that phrase, because the model said so. It's just not a viable defense. Not anymore. Look, in any high-stakes field, we're talking legal discovery, compliance audits, financial risk scoring, every single output needs a trail. You have to be able to trace an AI's conclusion all the way back to its source data. You've got to show exactly what was known, what was just a claim, and what was an inference. If you can't do that, you're basically just operating on faith, not facts.
Okay, so the big question is, how do we actually build this trust? How do we get there? Well, the solution is a really powerful framework called the three-layer model for truth. Think of it as a new way to engineer AI that you can actually trust. The whole idea is to systematically separate different types of information. And you do this before the AI even gets its hands on the data. It's all about creating a solid foundation from the get-go.
So let's break this down. It's actually pretty straightforward. First up, you've got layer one, the facts. This is your hard, verifiable data, stuff you can prove, like the FDA approved drug X on April 17, 2023. It's objective, it's traceable, simple. Then you have layer two, the claims. This is for things people or organizations say. So something like, company Y claims their new drug reduces symptoms by 40%. See the difference? It's an assertion, not a proven fact. And it's really important we know who said it. And finally, layer three, the interpretations. This is where you put all the inferences, opinions, and even judgments made by a model. For example, experts are feeling optimistic about long-term adoption. Now here's the absolute golden rule of this whole system. An AI can never, ever promote a claim or an interpretation up to the level of a fact. That promotion can only happen with cold, hard evidence.
And you know what's really interesting? This whole layered approach isn't some brand new crazy AI concept. It actually mirrors how people think rigorously in other fields. Take legal reasoning, for instance. You have raw evidence which is used to support the factum probandum, which is just a fancy Latin term for the core facts you're trying to prove. Or look at knowledge management systems. You often see a similar pattern. You observe a phenomenon, you interpret it, and then you synthesize it. So this isn't just about AI, it's a universal way of thinking clearly.
All right, so the theory is great and all, but let's see how this model actually works in the real world. We're going to look at how this framework applies in two totally different domains. First, the super complex world of legal AI, and then the really fast-paced environment of customer analytics.
So first, let's take a legal setting. Here, the mapping is incredibly direct and, honestly, really powerful. Your layer one, the facts, that's your raw criminal evidence. Think witness testimony you pull directly from a document. Layer two, the claims, these are what lawyers call the interim probandamum. Basically, they're the smaller, specific points you have to prove one by one to build up your bigger case. And finally, layer three, the interpretations. That's the actual legal reasoning, the human experience that connects the evidence to those claims. When you lay it out like this, the entire argument becomes transparent and way more defensible.
Okay, now let's switch gears and apply this to the business world, specifically mining app reviews. The raw, unfiltered user reviews, that's your layer one, your facts. It's the ground truth of exactly what a user typed out. Now, within those reviews, when someone says something specific like, please add multiple tabs, or this button is broken, that's a layer two claim. It's an actionable assertion. And then, the overall user sentiment, the I love this app or this app is terrible, that's a layer three interpretation. And why is this so useful? Because separating these things lets you respond to actual bug reports without getting sidetracked by general fuzzy opinions. Okay, so we've got the model, we see how it works. But the next logical question is, how do you actually build it? Well,
This isn't something that just happens. It requires a really deliberate engineering pipeline, one that's designed from the ground up to create what we call defensible knowledge.
This data journey really has three main steps. First, you capture the raw data. For example, you might ingest raw audio and use a transcription service to create a perfect, unchangeable record of exactly what was said. Second, you structure it, and this part is absolutely key. It usually involves what we call a human-in-the-loop process, which just means you have people and AI working together to correctly label every statement as a fact, a claim, or an interpretation. And finally, you connect it all. You build a defensible knowledge graph. You can just think of it as a smart, interconnected web of your data, where every single piece of information has a clear origin and a specific evidence level.
Now, a really important part of this whole process is proactively hunting for the gaps. I love this idea. A truly defensible system doesn't pretend it knows everything. In fact, it's specifically designed to flag what it doesn't know. The whole goal here is to find the holes in your own knowledge before a regulator, a customer, or, worst of all, a lawyer finds them for you.
So, after all this work, what's the ultimate payoff? What do you get out of it? Well, it's not about getting a slightly more accurate answer. It's about fundamentally changing the entire nature of what the AI gives you.
And we know for a fact these structured methods really work. There was a study on a framework called Surminer, which does exactly this. It separates user review data into those layers, and it achieved an F1 score of 0.81. For those who don't know, an F1 score is a key metric in machine learning that balances both accuracy and completeness. And trust me, getting a score over 0.80 on a task this complex is a huge deal. It just blows away methods that treat all the data as one big jumbled mess.
So here's the bottom line, the most crucial point of all this. When you engineer for truth, the output of your AI system is no longer just an answer. It becomes a defensible artifact. It's provable, it's citable, it's a record that shows you precisely what was known, what was claimed, and exactly how a conclusion was reached. What you have is an auditable chain of evidence that can stand up to scrutiny in a boardroom or, yeah, even in a courtroom.
And all of this brings us to one final, critical question for you to think about. As AI gets more and more embedded in everything we do, it's not a matter of if it'll be challenged, but when. So you really have to ask yourself, when your AI is put on the stand, when it's being cross-examined by a regulator or a really tough client, are you going to have a defensible answer? Will you be able to defend its logic? Or are you going to be left with nothing but because the model said so?